I've cleared the screen and I'm printing out the start text here at the top. And down the bottom, if we jump there, we see the inputs to the model. Initially, you've got current text that has the 9 tokens start text, which you see decoded at the top here. There's no past state yet. We do have outputs. We have the initial logits from running in that start text. We get the initial logits out. It's not obviously showing all. That would be impossible on the screen. And there's a new past state, which represents, you can see all the different layers. And the 9 here represents the history so far, which is these 9 tokens. And this number, you'll see it'll increase, right? The next pass, 9 will be in the input side and 10 will be on the output side. 10 will, then, 11 will be on the input side and 12 will be on the output side. And it'll just increment one by one for the rest of the time. But here it's showing the sampling. This big string here is showing the top 40 tokens as would be selected by top K with set to 40. You can see the decoded token and the probability. And then this is what would be picked via multinomial with whatever random seed is set. And then this is the argmax, which should be the same most of the time. And this is just some other things. Is it in the top 40? I just wanted to make sure I was sampling from the top 40 and some temperature settings. So let's see, if I go and hit enter, it'll go to the next iteration. We can see now we've got an input state, or the past, right, was now sent into the model. Now out came a different new past, right? And we can see the number incremented. We can see the word that's picked, and it's stringing out at the top. So if I can just step through this to see each token that gets generated, and I think it's really interesting to just see like what were the tokens in the top 40 and what were the probabilities associated with them, and what was picked. Like at this point, the presence or absence of a dominant. Dominant was picked with multinomial sampling, right, which is in the top 40. But the highest probability one is single. The presence or absence of a single is the most probable one, with a probability of 0.23. Where is dominant in here? There's dominant, 0.03. So you can see how multinomial sampling gives you their variability. Sometimes these are the same, sometimes they're different. This is an interesting one because we kind of reached this interesting point where as or and are picked up, but you can see all the other top candidates is all this punctuation. Well, it's not all punctuation, but there's a lot of punctuation or these kind of connecting words. I'm not sure what the technical term is. Here we can see 2 is the highest probability one, and it's picked by argmax and multinomial. At some point here, if I jump ahead, we get into, I think, a line break or a new line character, which I thought was interesting. I can just let it rip, but I want to find this one because I thought it was interesting that we have, there we go. So once we get to these punctuation points, right here, this extra space, I think it's a new line character, even though it's not being translated as a new line up here. Most of the tokens here are all punctuation, and end of text is a character there. Or you can see like however, right, which might be how you would start like a new paragraph. So all these things kind of, it's just interesting seeing how these things are selected. And here I'll just hit S and let this continue until the end, right? And so now we've reached the end based on that test. If you look at the bottom, the Levenshtein ratio for what was generated here compared to the reference is 82, threshold is 70, so I guess it's pretty good. Anyways, this helped me understand how this model was working quite a bit. Hopefully it helps fill in some blanks as well.